part 2 of the summary video concerning the CVP analysis. So in part first, basically, we understood a little bit dynamics of what we call the quantity produced and sold, total revenue, and total cost. Now, this particular point right here, where the two curves are the total cost and the total revenue lines on the graph, they intersect. This particular point is what we call the break-even point. So this particular point is what we call the break-even point, right? So this is the break-even point. And at this particular unit, the quantities produced and sold they're basically equal to 125, where the total cost and the total revenue equals 8,755. So if we drop down a vertical line like this, pardon this line, and if we draw a horizontal line, something like this, so this point right here and this point right here represents this one represents basically what we call the break-even volume, which is represented by X subscript BE. And this one right here represents a point which we call the break-even revenue. So let's call it a TR subscript BE. So in this particular point, you have no profit, no loss. And if we produce certain kind of amount of products and sell them, so you'll reach the break even. So you can segregate this a little bit more. So if I consider it something like this, if I consider this point right here, it's a little bit bigger one. Let me use another color. So let's suppose a blue one. And this region right here. So any region beyond this blue line, above this blue line, is where you have the profit. And any region below this blue line is what we call the loss. Similarly, if we consider on the x-axis, so any produced unit below 125, that will basically represents the loss, and any unit produced beyond 125 is what result in the total profit, right? It will represent in the profit. Now, notice one thing. I'm going to get rid of these lines so that I can show you some of the relation between the selling price, the variable cost, the fixed cost, and the break-even point. So here you go. I'm going to rub this one a little bit. Let's get rid of these label axes as well. So here you go. So this is basically the break-even point. Now observe, if I change the selling price, so suppose I'm going to increase the selling price. So you'll notice that when I increase the selling price, this break-even line will shift towards the origin. So it's something like this. So if I make it 90, so see, before the break-even point was somewhere here on 125. Now the break-even is basically shifted right here. Similarly, if I now decrease the selling price, so initially the selling price was 70. So what if I make it, suppose 40, right? What will happen? This break-even point will then shift away from the origin. So this means on a low selling price, you need to sell more products to reach the break-even. So here you go, 40, and when I click here, so here you go. Now, what does that mean? This one basically means that if we keep the selling price 40, and the fixed cost, variable costs, they do not change, then at this particular selling price, we cannot even get a break-even. Let's make it, let me make it 60, and let's see what happens then. On 60, now it can break even, right? Let's make it 50. What happens at 50 selling price, right? So at 50 selling price, again, you can break even. But if you observe this region right here, this region, this is basically the break even, and this region right here represents the region of loss, right? This represents the region of loss, and above the break even point, this region basically represents the region of profit, right? This basically represents the region of profit. So you see the profit region shrink a lot, and the loss region basically it expanded. Now let's make this these values again the default values, which were basically 70. So I'm going to make it 70. So you see, and I'm going to get rid of this one. So once again, this is the break-even point. So anything above the break-even point is what we call the total profit. So between this blue total curve, total revenue curve, and the orange total cost, the region in between is what we call the profit region. And similarly, if we consider a region below this break-even point, below this point right here, is what we call the loss region. So what we actually inferred from this activity is that when we increase the selling price, the break-even point, which is this point right here, will always move close to origin. So it will basically move to origin. So in other words, the break-even volume it will decrease, and vice versa. Similarly, if I decrease the selling price, then this blue dot right here, which is the intersection between these two, total revenue and total cost lines, right? So they'll basically shift away from the origin. Now let's see what will happen if we change the variable cost right here. So let's move towards the variable cost. So the variable cost per unit is suppose 30. Let's make it 40, and let's see the impact of it. Or let's make it 50, and let's see the impact of it. What basically happened is when we increase the variable cost, right? So this is now the variable cost. When we increase that, then the break-even volume will also increase. So the association between the selling price and break-even is what we call an inverse association. If one variable increase, the other one will decrease. So basically, when the selling price increase, the break-even will decrease. On the contrary, if we increase the variable cost, the break-even volume or the break-even point will shift away from the origin and vice versa. Similarly, if we decrease the variable cost, the break-even point will basically shift more towards the origin. Now let's make the values again, the default values, which were basically $30 per unit. Now what happens if I change the fixed cost value? So here the fixed cost value is 5,000. So notice that if I change it to 6,000, what will happen? Again, you see the break-even point basically shifted up. The original break-even point on when the fixed cost was 5,000 was basically 125, but now it got to 150. So this again means that if we increase the fixed cost, then the break-even volume will basically increase, and this point right here, the break-even point, it will move away from the origin. So that is what the CVP analysis is all about. How is it beneficial? So if you manually calculate all these values for all these units, it will take a lot of time. But in Excel, if you fix some functions, if you apply some equations, with a single click, you can basically know the values at each and every point, at each and every unit which you can produce or sell. And that gives you more flexible dimension in the decision making. So that's the end of this summary, which concerned the CVP analysis.